Hi everyone, this is a quick video just to explain this basic construction of a nut that we are going to transform from a 2D to 3D drawing. This example comes from the JPEGD workbook, page 62 on the left hand side, and it is the 2022 version. Let's take a quick look at the question. In the question, it says there the front view and the top view of a model in third angle projection has been provided. The position of point S on the drawing sheet. Let's just identify that. So first of all, this here at the top is our top view, and below it is our front view, and we have starting point S on the top view over there. Please note that it's not attached to a corner, so we see that there's an imaginary line that is going to be where point S is, and then on the front view point S is easy to identify. And we know it's the front and top view because we are provided with the third angle of a graphic projection symbol. We have to start with the auxiliary view, and once we've done the auxiliary views 2D, remember that it is seen at an angle of 90 degrees from the top. And then we're going to do the answer after we've done the auxiliary view, which is also our help view, and transfer the information, the measurements that we have on that 2D auxiliary view onto our answer, which will be in 3D isometric. I'm going to go to my question and label your views of your top view right here in your questions. So we have the starting point S here on the top view. We've got number 1, we've got number 2, 3, 4, 5 and 6, and all those same numbers will correspond over onto our front view. I'm not going to put them in now for the sake of time. The front view will obviously show us corners 1, 2, 3 and 6. 4 and 5 would be behind 2 and 1 at the back of the front view. Let's start with the auxiliary view. Now, the rule that we need to apply for the auxiliary view is that we need to understand the construction rules for a hexagon. The hexagon construction rule says if the base length is a certain distance, then the construction circle that we use to construct that hexagon is equal in length or radius to that base length, which is then in this case 42 millimeters. What does that mean? It means we will set our compass to the base length of 42 millimeters, and we will draw a construction arc of 42 millimeters radius. So I'm going to go to center point O, and I'm just going to draw that arc, a construction arc, and then I'm going to clear all the construction. So that's your first step. Draw the half arc with a radius of 42 millimeters. Then you move to either one of the ends on the x-axis of the center line. So I'm going to go there. You anyways will leave your compass at 42 millimeters, but it will work out the same to the center obviously. And we will just draw in that arc, and then we move to the other side, and we will draw in the arc on that side and cut it off. Now we have all of the 4 corners that we need. Once you have done the constructions for the 4 corners of your hexagon, you are going to plot a reference point at each one of the intersections. I always ask the students to place in those, and then we are going to draw in solid outlines. I'm going to thicken this line just to make it more visible and make sure that we can see the outlines of our hexagon. So these will draw in solid. Then we have the hexagon, but we have to still box it. We use the term boxing so that we have something to work from as a reference point when we do the transference of our measurements. So this is how we box it. Yeah, and you could do it on the other side as well, but it's actually only needed here. And then we can just go and label that corner S, because that is the label for that corner in relation to what was given here on our question. Good. So now we have our auxiliary view or / help view done. Now we're going to take all of this information over to our answer. So we're going to start with point S. As you remember, this is now the 2D orthographic view of the nut from the top, and then we are going to transfer it here to the 3D answer. So I'm going to measure now from starting point S the distance to the very first point here. That's 21 millimeters, and while we're at it, let's just grab these labels here and carry them over so that we synchronize what we've done in the question. Six corners, 4 and 5 obviously is there. You can see it on the question. That's why I wrote it on here, because we obviously won't see it here in our answer. Good, so once we've done that, we are going to use those reference points and carry them over. So we already said from S to 1 is 21 millimeters. So from here, we're going to go and project a construction line. So I'm going to just draw from point S indefinite length of the line, 30 degrees to the left, which on CAD is 150 degrees. And then also immediately I'm going to go and draw then also an indefinite length of 30 degrees to the right using your 30 degree set square. Once we've done that, we can now go and measure from point S the distance of 21 millimeters and place our reference point there. So we know that is going to be number 1 over there. And once we have that, we just go back to our auxiliary view. We go and we know already that the base length is 42 millimeters. It's 42 for all of the base lengths. Right, that's the rule of a hexagon. All base lengths are equal in length. So from 1 to 2 is 42 millimeters. So we don't even have to measure that. We should know it. So that's tab 42. That gives us our reference point 2, and we label that immediately. I always recommend to label immediately once you have placed the reference point. And now obviously if it's from S to 1, 21 millimeters, it will be from 2 to the far reach. So that means that distance here would also be 21 millimeters because it's a symmetrical shape. So I'm going to go now from 2 and I'm going to measure another 21 millimeters further on to the left. And I'm going to place a reference point. And you can call it something if you want, or you don't have to. In this case, I'm just going to let it be. And then what is nice is that we can now actually either draw the parallel construction lines at number 1, 2, which is parallel to the z-axis. Because we know this is the z-axis on the right hand side, because the z-axis provides for us the depth of our nut, as where the x-axis, which is where we are busy with now, that is our front view in third angle. Place your 30 degree set square, and from there just go and make sure you snap. If you're doing this in CAD on paper, you just draw all the way. I'm going to extend the lines just now, and you will see exactly how it comes to that reference point there. Always zoom in and out if you're drawing on CAD. Make sure of those snap points. Now on the z-axis from S to 6, obviously that wouldn't be 42 millimeters, so you have to go measure it. Use your divider on paper. Here on CAD it's 36.37. So we're going to go to S, tab 36.37, and we're going to plot that dot on the distance. That will give us immediately point number 6, or corner number 6 of our hexagon. Good, so now I actually don't have to do any other measurements, because what is nice about isometric drawings, from here I can just go and use what angles I have to the left and the right, and I actually end up with the right distances. But let's just do what we can in the meantime. So I'm going to go and draw parallel to the x-axis through number 6, but I also remember that number 6 is where the center line is going to be. So I'm just going to go and take that line and extend it just past there and just past the extents there, because I'm going to change it now immediately to a center line. And the pen tool, always use the one from the top. When you print out, that tends to be the best. You always align, you always say there 0.2 or 0.3, whichever you prefer, depending on the scale you're working on. And I want to change that color to blue. And there I have my center line, which represents this one here from 3 to 6. So immediately I must know that from 6 to center point O is 42 millimeters, and from center point O to number 3 is 42 millimeters, because that's another rule for a hexagon construction, because we know that the construction circle's radius must equal that of the base length, right? So that means we are going to immediately go and just measure it either from a point S or 6. In this case, S will snap easier. So I'm going to just go and write 42. And from there, I'm immediately going to take that parallel line and take my set square on paper to do this. Let me just extend that line a little bit past, because it's also going to be a center line. I'm going to clear that water line. Remember, in CAD, as I always say in my other videos, I use the water lines to measure. And by the way, this is TurboCAD 2021, if you want to know which version this was. So what I want to do is I want to change this line now to there, and I immediately am going to go and change the line properties. You either right click and say properties, or you can double click on the yellow dot, whichever you prefer. Go to pen tool, select the center line from the top, change that to 0.3, align it and say okay. Good, and then we can change the color. You could have changed the color in the settings panel as well. I just like to do it here. Now I have my center line, and the hexagon is a symmetrical shape. So that means if I go now here, and let's just label this for the use of the tutorial. If that is O, right, center point O, which correlates with center point O here in our auxiliary view. Now on our 3D answer, we just take our divider or our compass and we measure to that distance. In this case, it's still 36.37 because it's the same distance as from S to 6. But I just use this as a quick method and plot there at the far end, that reference point there, and that would be the other reach of my hexagon. So remember, from 0 to there is the same as from 6 to S or S to 6, doesn't matter. So that distance is the same on the other side. So I'm going to go parallel to the center line and draw through that 130 degrees in that direction, another construction line to here, and now I can immediately start doing housekeeping as well. And then we also want to just shorten the center line. Always take it a little bit behind the edge of your shape. So we have now boxed our hexagon. So now we could draw solid what we see solid, and we could draw light what we see light. But before we get there, I'm going to draw in a reference point there, there, and there. And the reason for that is because we know here's number 1, there's 2, 6 and 3 is aligned with one another. So let me just move 3 a little bit out. And then when you look at number 2 and 1, in your question, you'll also see 4 and 5 is aligned with 2 and 1. And then we just carry that over. So with 2 is 4. We always go chronologically, so that's easy to do. And then number 5. And then we have all the labels for our hexagon. It depends on which way you want to go. Some people draw the top part first and then do all of this. They don't necessarily do it on the base. I like to start off with the base. So what I'm going to do is then just draw in the outlines, the light construction outlines, to show the shape of my hexagon, just to keep my bearings straight and to see what I've done up to this stage. And there is the shape of my hexagon transferred from 2D to 3D. But the answer doesn't end there, because I see on my front view there's a height of 22 millimeters. So it is raised, this nut's thickness or height, whichever you would like to say, is 22 millimeters. So I must now go to each one of these reference points, and I'm going to go and draw a solid line that's vertically 22 millimeters in length and at an angle of 90 degrees. Just project that up from each of these reference points. There are other ways to go about this. I just do this, short and sweet. Use your set square and ruler in combination to do this on paper. As I said, there are other methods to use. And the number 6. And now we have these 6 pillars from each of the reference points. So all of these outlines at the top will be visible, but clearly you can see here at the back from 2 to 3, 3 to 4, 4 to 5. Those will be hidden detail. Now you have to read the question and see, do they ask for hidden detail or no? So they said no hidden detail is required, so I'm not going to bother changing those construction lines to hidden detail because it's not necessary. However, the outlines must be solid, so I'm again going to use a very thick line here for the sake of the tutorial and just draw in solid what must be solid outlines. And let's do it at the base as well. Now on CAD you can actually just select those lines. Let me show you. So I can select the lines holding in shift and then clicking on the ones that I want to use. Those is the lines that I want to use, and simultaneously go and change them all once they've selected. Now then I can see, oops, there's a color that I must change, so I can just go and change that also. Sorry, and there we go. There is the base and outline of my nut, but we should not throw away the circle. You need to just go and carry over from here the information that's given with a diameter of 42 for the circle, which means it's a radius of 21, which is important, from the center to the left and to the right and up and down. So you need to box that circle first for the construction. So let's do that very quickly. So I have to draw in my center lines here at the top as well. So all I'm going to do is on CAD, I'm going to cheat a little bit because I have the ability to do this here in CAD. So I'm going to take that center line, and I'm going to just change the line width to there and then just bring that up. And I'm also going to take this one. So it is already snapping to the midpoint, but you obviously will go and measure that now. So I just want to draw that center line very quickly from there and extend it a little bit beyond. Let's do it. Let's take off the snap for a moment. There we go. And then we're going to change that line property. So I select those two, the quickest way, double click on the yellow dot or right click properties. And then from there I'm going to say center line, scale 0.3 and the line. I could have changed the color there, or I can change the color here for the center line. So there's my center line right in the center of the top layer of my nut. And now I want to draw the circle. So we see that our center lines go right through the middle. So that's important to make sure. Is it always going through the middle? It could be off center, but in most cases we give it to you in the center. And then what we need to do is go and draw construction lines. Now we're going to box first our construction. So we're going to go 21 millimeters, which is half of the diameter, to the left. And let's change the line color now to gray so that it is a construction line starting off with. So I'm going to just go and change that to gray there as well. And then from the center, it's going to be 21 millimeters now also to the other side. Then from the x-axis of the center line, I'm also going to go 21 millimeters displacement upward. From the center line downward 21 millimeters. So it's 21 millimeters in all directions from the center of the construction. So I want to grab that. That's tab minus 21. There we go. Lengthen those properly. So please do this housekeeping as you draw, especially on CAD. On paper you have a little bit more grace, but also try and keep it as clean and smooth as possible. So there is the square that is now transferred 30 degrees onto the flat surface of the 3D model. So it is now not it doesn't appear to be a perfect square, although in reality you would know it is a perfect square. But we are going to draw in the construction lines for a isometric circle. Now I have got tutorials on the isometric circle, so you can watch that, but let's just go very quickly through it. So from the corner that appears to be an obtuse angle to the opposite middle is where I'm going to project from this obtuse angle to what appears to be the opposite middle there, and then from the acute to acute through the center there I have the construction of my isometric circle. I go into more detail in my tutorial, but this is the full construction. So now I know on my top layer of the nut, that is the construction for my circle. So all I need to do is go and draw in the circle. So I'm going to draw it as a dark solid line, and I'm going to emphasize the thickness. So you can decide which you want to do, the large or smaller circles first. I'm going to place my compass here on this so-called obtuse angle, and then stretch it to the opposite middle, and then draw that solid arc from the opposite middle to the other opposite middle. Obtuse angle to this one, because we have to work anti-clockwise. So no, sorry, again I have to go to this outside edge, be careful of that. And then we're also going to go to this pressure point here, and then to the opposite middle we have to work anti-clockwise in CAD. So let's do that. And then also on this pressure point, and what we're going to do is we're going to anti-clockwise, I must always remind myself, and draw that arc in there, and there we go. There is our isometric circle. So what we need to do now is, obviously that's a hole that goes right through from top to bottom in our nut. So we need to show the inside curve of the thickness as well. From this obtuse angle, we're going to draw a line straight down at 22 millimeters at an angle of 90 degrees, or in other words 270 degrees in CAD, so that we can get this corner. So we've just transferred this pressure point of our construction for the circle and projected it 90 degrees down at a distance of 22, because we know the thickness of this, or the height of this nut, is 22 millimeters. And what we're looking for is that here we had the pressure point for this large arc here at the top. So that's the arc that will be exposed here when we draw the thickness and the inside curve. We just had to take that pressure point 22 millimeters down. But we're going to draw it as a construction arc first, not as a dark solid line at first. And you'll see now, because it actually requires that we do another construction after that. But so what is it that we need to do is we need to take the radius from here that we had to there, and that distance was 42 millimeters, right? So what we need to do is we need to take that same distance as, say, 42, just a construction arc, right? We're gonna cut it off later. So that's just, you don't have to draw the full circle. I'm CAD, I just had to do that because I'm going to cut it off. But now there is a curve coming a little bit to the left and a curve coming a little bit to the right on this depth that we need to consider. So we also need to take this pressure point over here and that one over there 22 millimeters down. So please don't jippo, do this, draw in that construction. I know many people don't like to do this, but that's the right thing to do. So we're going to take it 22 millimeters down at 270 degrees, and we're going to take this one down as well, 22 millimeters at 270 degrees. And now we can also just indicate that. I always tell the students, make sure you indicate those lines first of all, and then the reference point where you're going to place your compass, because it is part of your construction. You are not drawing the full construction of your isometric circle, so you have to indicate these constructions just to get those marks for the construction if they are allocated. Okay, so the long story to get to the point here is that I'm going to take now the radius of this smaller arc that I have here, which is 14 millimeters, and I'm going to apply it here, and you will see what happens now. So in my drawing, I'm going to go, and let's just use in CAD the water tool for this purpose. So I'm going to go tab 14, and then also over here tab 14, just to give myself the reference point. And now what you will see is, do you see that there is actually a little bit of a curve there? Okay, on paper you wouldn't see it that clear, but obviously here you will see it in CAD if you do it. So if you're doing this as a draftsman, obviously you must draw in that curve properly, because you need to do this accurately. So what I'm going to do is I'm going to go and draw now solid the arc in there, and I'm going to make it also a thick line in for the sake of this tutorial. And I'm going to use the arc, and I'm going to place my compass here with that radius of 14 millimeters. I'm going to go to where they intersect with one another. It's only for all the work for that little bit of arc. Can you believe it? And then I'll do the same on this side, also pressure point, and I'm going to stretch it to that 14 millimeters and just anti-clockwise. My apologies. So go to there, anti-clockwise in that direction to where they intersect, and then I go to this one here at the bottom, and I'm going to do that arc here now solid. So from there all the way to there, and then I can erase that line and the water lines as well. And there we go. There is the hole, also indicated correctly using this shortcut method of transferring the depth. But we will still get all our marks because we have indicated. If you want to, you can give it a label as well. Say, let's for example say that was A, and then that one will be A1. You could say that one is B and that one B1 if you want to. Okay, the same with this one here. Okay, that is, but as long as you show the line, show the reference point, you will get your marks. And that concludes the construction of isometric nut transferred from the 2D orthographic views in the question in third angle onto our answer in 3D isometric.